Good morning, students. Today we will start doing numericals of calorimetry, the second part, exercise 11b. Okay, so before we start doing the numericals, just want you to know the formula that will be required here. First, Q is equals to MC delta T. Okay, and then your Q is equals to MC delta T. Okay, this we will use when there is a change in temperature. Okay, when there is a change in temperature, and then Q is equals to ml. This when there is no change in temperature, but there is only a change in phase. Okay, that is when there is a change in phase, that is they will be melting or freezing, so like that type. So there is no change in temperature, but there is a change in phase. That time we will use Q is equals to ml, where m is mass and L is the specific latent heat, okay, of fusion of ice. And then the next formula that we are going to use is heat absorbed is equals to heat evolved. Okay, heat is the same Q, so heat absorbed is equals to heat evolved, or in other words, the same thing, we can write it as heat gained is equals to heat lost. Okay, so when you are mixing, this type we will use, and this is actually principle of method of mixtures. Principle of method of mixtures, and this type formula we will use when we are mixing two things. Okay, suppose we are mixing ice with water, so that time ice will gain heat and water will lose heat, right? So like that, so we will use these formula that time. So let us now do the sums. See the first question. 10 gram of ice at 0 degrees Celsius absorbs 5460 J, that is joule, of heat energy to melt and change to water at 50 degrees Celsius. Calculate the specific latent heat of fusion of ice. That means we have to calculate L. Specific heat capacity of water, that is C, is given 4200 joule per kg per Kelvin. So remember, in this question, 10 gram of ice, okay, is changing to, it is getting some, it is absorbing this much of heat, and it is melting and changing to water. That means there is a change of ice, which is always, ice is at 0 degrees Celsius. Okay, so here it is given also, I think, yeah, ice at 0 degrees Celsius it is given. So ice, which is 0 degrees Celsius, will first change to water at 0 degrees Celsius, then it will change to water at 50 degrees Celsius. Fine. So when it changes from 0 degrees Celsius to 0 degrees Celsius, that is a change in phase, what formula we will use? Q is equals to ml. Okay, this much heat energy it has absorbed to change from ice to water. Okay, and then Q is equals to MC delta T. This formula we will use when it changes from 0 to 50 degrees Celsius. Fine. So the total heat energy will be this plus this. So here we are. All the given part is written here. Fine. So the total heat is Q is equals to ml plus MC delta T. Q is given, M is given 10 grams. Okay. And always check the unit. If here it is gram, here also should be gram. Here it is given in kg now, so it is converted into gram. Okay, so this you can remember. Like always, either you can remember 4200 joule per kg per Kelvin or 4.2. Otherwise, remember that you have to divide it by 1000. Okay, so here M, in place of M you have put everything. C, you have put delta T, you have put delta T is nothing but 50 minus 0, because 0 to 50, so the difference is 50. Okay, after that multiply this and you'll get this. Okay, multiply this 10L, leave it as such, 2100, you bring it to this side, so it will become, I have just written it this side, but I have brought 2100 to this side, so it is 10L equals to 5460 minus 2100. Clear? Fine, I have brought this 2100 this side, only I have written that in the right side. Okay, after that we need L, latent heat, so 10 you divide it, you'll get your answer to be 336 joule per gram. Yes, easy. Second question. How much heat energy is released when 5 gram of water at 20 degrees Celsius changes into ice at 0 degrees Celsius? So now there is a change from water to ice. Okay, so take specific heat capacity, that means C is given 4.2 joule per gram per Kelvin, and latent heat is also given 336 joule per gram. Okay, so we need Q. How much heat energy, quantity of heat, it is all given as Q. Okay, so whatever is given is written here. Then remember to make this will be very easy. Okay, if you make it. So water at 20 degrees Celsius will first change to water at 0 degrees Celsius. Read the question and understand this diagram. Water at 20 degrees Celsius will change to 0 degrees Celsius. Then from water 0 degrees Celsius, it will change to ice 0 degrees Celsius. Clear? So here when there is a change in temperature and there is no change now from water to water, so there is only change in temperature, MC delta T. So here there is a change in phase, but there is no change in temperature, so there is no delta T. Here it is ML. So total heat will be Q1 plus Q2. That means MC delta T plus ML. Okay, so M, how much it was? 5 gram. Okay, then C, how much? 4.2. Okay, then delta T 20. Clear? M, same 5 gram into L, given 336. Multiply this, you'll get this. Multiply this, you'll get this, and then add it, you'll get this answer. Clear? Understood? Question number 3. A molten metal of mass 150 gram is kept at its melting point. Clear? Molten metal means it is at liquid, like that form, right? 150 gram, it is kept at its melting point. Melting point is what? The point where it starts changing its phase. Okay, so 800 degrees Celsius is its melting point. When it is allowed to freeze at the same temperature, it gives out 75,000 joule of heat energy. Okay, freezing means it is going to change, okay, its phase. So what is the specific latent heat of the metal? That is heat of fusion of the metal. And then if the specific heat capacity of the metal is this much, that means C is given, how much additional heat energy will the metal give out in cooling to minus 50 degrees Celsius? Okay, so let's do the sum. The metal is at its melting point 800 degrees Celsius, and it is changing to the metal, that is the metal with it is at its melting point, right? So it is going to change from, it is written that it is allowed to freeze at the same temperature. Okay, so that means it has to, when it is freezing, it is giving out heat energy. Yes, so whenever it is giving out heat energy, it will again, it is changing from liquid to solid. Okay, so here the answer, you can see that at how much it is? Minus 50 degrees Celsius. So what will be the delta T? Delta T, which one is higher? This 800 is higher and minus 50 is lower. So we always used to subtract from the higher to the lower. So 800 minus 50. Okay, so minus will become plus, so total will be 850 degrees Celsius or 850 Kelvin. Okay, here you can see that there is a change in temperature. There is a change in temperature. Okay, so just like here you could see that water at 0 degrees becoming water at 50 degrees. Yeah, or here you can see water at 20 degrees becoming water at 0 degree. Here also the metal is changing here 0 degree was the change, the temperature melting point of that ice to water, no? 0 degree only. Same way here, metals melting point is 800. So we are doing MC delta T here now. So delta T we found it here. Okay, and then so Q is equals to ml. We have to find out latent heat. Q is equals to ml. L is equals to Q by m. Okay, Q is already given, m is also given. So from that we could find out latent heat. We don't know the L. In the question they are asking us to find out the L. What is the specific latent heat of the metal? So this is the latent heat of the metal. Okay, now we are changing 150 this one, the gram to kg, in order to find out Q is equals to mc delta T. Okay, so here it is written that the second part, if C is 200 joule per kg per Kelvin, how much additional heat will be required to give out, will the metal give out in cooling? Suppose I have to cool the metal to minus 50 degrees Celsius. Okay, that is actually, this was the first part to find out latent heat. This is the second part. Clear? So how much heat will be required to change from 800 to minus 50 degrees Celsius? Okay, so this is the heat required. M value you have to write, C value you have to write, delta T value you have to write, and then multiply, you'll get this. Okay, why I have changed to kg? Because you could see that C value is joule per kg per Kelvin. So one cannot be gram and another cannot be kg. You have to change one to all the thing to one system of unit. Okay, so that you'll get joule here, 25,500 joule. Clear? Fine. So now question number 4. A solid metal of mass 150 gram melts at its melting point of 800 degrees Celsius by providing heat at the rate of 100 watt. So 100 watt means power is given. Okay, temperature is given, mass is given. The time taken for it to completely melt at the same temperature is 4 minutes. Time is given. So what is the specific latent heat of fusion of the metal? That means we have to find out L. Okay, so whatever is given here, written down. So you could see that 150 gram, it is changed to kg. So it is 0.15 kg. Power is 100 watt. Time is 4 minutes. So change it to seconds. You know Q is equals to power into time. Okay, energy is power into time. Power is given, time is given, multiply it, you'll get this. Okay, and after that, because other C, delta T, nothing is given there, right? Only your power and time is given. So from that only we have to find out. So this is a new formula here, right? We know that Q is equals to ml. So L will be equals to Q by m. Okay, so what is Q? Q we have found out to be 24,000. M 0.15. Okay, so if you cancel it, you will know that the answer is 1,60,000. Okay, so that you can write it as 1.6 into 10 power 5 joule per kg. Clear? Question number 5. A refrigerator converts 100 gram of water, okay, at 20 degrees Celsius to ice at minus 10 degrees Celsius in 73.5 minutes. Time is given, mass is given, temperature change is given, 20 degrees Celsius to minus 10. Okay, so the specific heat capacity of water is given, latent heat of ice is given, specific heat capacity of ice is given. And we have to find out average rate of heat extraction in watt. So this is our clue. In watt means they are asking us to find out power. Okay, so we have to find out power. So we know the formula, Q is equals to P into T. So P will be equals to Q by T. Remember that. So if Q is equals to P into T, P will be equals to Q by T. Clear? So this is our main formula. From here we have to find out Q is equals to, we have to find out the total heat energy and divide it by time. So it changes from water 20 degrees Celsius to first water at 0 degrees Celsius, then water at 0 degree to ice at 0 degree. After that only it will go to ice at minus 10 degree. Okay. So whenever there is a change in temperature, mc delta T. When there is no change in temperature, ml. When there is a change in temperature, mc delta T. Clear? Okay. Now we have to add the whole thing up. So how much heat energy will be, how much heat energy will be given out? mc delta T plus ml plus mc delta T. Clear? So we will add up the whole thing. So mc delta T, how much mass was that? 100 gram. So 100 gram, okay, into C, 4.2. Delta T, in this it is 20, 0, 20. Okay, 20 minus 0 is 20. ml, m is how much? The same thing, 100. L will be how much? 336. Okay, and then this one, next one is mc delta T of ice. So m, 100 gram, C, this is for ice, C, okay, and delta T is this one, 10 minus 0, 0 minus 10. That's why it is 10. Clear? So remember, delta T can never be negative. Clear? So always it is positive. So you have to write it 10 degrees Celsius. The difference between 2 is 10 only. After that, multiply this right here, multiply this right here, multiply this right here, add up everything, you'll get this. This is your Q. Okay. After that, power is equals to Q by T. So Q, write the answer here. T is 73.5 minutes, right? So into 60 seconds. So 73.5 into 60. After you do the cancellation, you'll get this answer. So when you cancel this, you'll get 10 watts. Clear? So this is your answer. Next question. In an experiment, 17 gram of ice is used to bring down the temperature of 40 gram of water. That means you are mixing ice with water. Ice you are taking 17 gram, water you have taken 40 gram. And water is at 34 degrees Celsius. And you are mixing the ice to bring the water to its freezing temperature. Okay. The specific heat capacity of water is this much, 4.2 joule per gram per Kelvin. Calculate the specific latent heat of ice. That means you have to calculate L. And you have to give one assumption that you have made in the calculation. Clear? So how we are doing here is, according to question, you are mixing ice with water. Ice you have taken 17 gram, water you have taken 40 gram. And then after you mix both, what happens? Water will, it is telling that we are bringing the water to its freezing temperature. Clear? So water at 34 degrees Celsius will change to water at 0 degrees Celsius. Okay. And ice, when you are mixing with water, naturally ice will also melt. Yes. So ice will become water at 0 degrees Celsius. Fine. That's why the arrow is like this. Okay. So here we will use the principle of method of mixtures. That is, heat absorbed by ice is equals to heat evolved by water. Clear? So you could see that when you are heat absorbed by ice, when ice is absorbing heat, it is changing its phase. See, 0, 0. That's why it is ml. So m, that is mass, into L. M is how much? Ice you have taken 17 into L. And this is m of water. Okay, that is 40. C, 4.2 of water. Delta T, there is a change in temperature, 34. Okay, after that you multiply everything, bring the 17 down, and then you do the calculation. You'll get L to be equals to 336 joule per gram. So what is the assumption made? Assumption is there is no loss of energy. Clear? That's why we have used this. Heat absorbed is equals to heat evolved. That means there is no loss of energy. Clear? So this is the way we do the sums from now on. From question number 6, sums are like that. You're mixing one thing with the other. So naturally one will lose energy, heat energy, one will gain heat energy. Clear? Question number 7. The temperature of 170 gram of water at 50 degrees Celsius. See, water how much you have taken? 170 gram. And it is at 50 degrees Celsius. After you're mixing it, you're adding certain amount of ice, it is becoming 5 degrees Celsius. From 50 it is becoming 5 degrees Celsius. Okay, the temperature of water is lowered after adding certain amount of ice. Certain amount means mass is not given. Ice mass is not given. Okay, find the mass of ice added. See, you have to find out the mass of ice added, and rest all things are given. Specific heat capacity of water is given, latent heat of ice is given. Okay, so how you're gonna do that? See, water you have taken 170 gram, and water will change after you're mixing water with ice. It is changing. Water will change from 50 to 5 degrees Celsius. Ice, which is at 0 degrees Celsius, okay, first it will change to water at 0 degrees Celsius. Yes, and then, because finally water's temperature should be 5 degrees Celsius, and when you're mixing both means both will be coming to the same. So water at 0 degrees Celsius, ice at 0 degrees Celsius will change to water at 0 degrees Celsius. Then this water at 0 degrees Celsius will become water at 5 degrees Celsius. Okay, finally the temperature of this water is brought down to this. Clear? By adding ice. So you know that when you're mixing one thing with the other, they are both in that mixture. Correct? So both are there, and the final temperature is given that we have brought down from 50 to 5 degrees Celsius. Clear? So here is the arrow mark. So here will be the equal sign. MC delta T equals to MC delta T plus ML. Clear? So heat lost by water is equals to heat gained by ice, or heat evolved is equal to heat absorbed. So for water it is MC delta T, which is here, I have written it here, and here it is for ice, which is MC delta T for ice and ML for ice. Okay, both are for ice, so M can be taken out as common because we need to find out the mass of ice only. Clear? So all the values you put it. This is for ice, so you just have to write every values here. Clear? And since here, though it is for ice, the C you have written for water, because in this case you can see that it has already changed to water. Clear? So you have to write 4200 into 5, that is a change in temperature, 0 to 5. Now 5 minus 0 is 5, and then ml, so latent heat is given here, 336,000, that one. Okay, and then you add it up, you get this answer. This side it is delta T 50 to 5, that is 45. Clear? C same 4200, and then this it is 170 grams, so it is changed to kg by dividing it by 1000. Clear? And after that you multiply, you get this answer. Okay, so this is equals to mass of ice into this. So mass of ice will be this divided by this. So this divided by this, it came out to be 0.09 kg. Okay, so when you multiply it, it'll get 90 grams. So mass of ice is 90 grams. Clear?